Okay, we have here today another integral from the MIT Integration Bee 1991. This one's problem 24. We have the integral of 1 minus 4x to the fourth to the minus 1/2 power over 4x to the minus 1 power dx. Okay, the thing that's really odd here is just that we've got these exponents, but we've got these negative exponents in the numerator and denominator. And it's kind of awkward to have these negative exponents. And I was thinking if we just flip this whole thing, we can get rid of the negative exponents and maybe it's going to be a little easier to deal with. So if I do that, and we'll just rewrite this, so 4x to the minus 1, I can just take this into the numerator and write it as just 4x. This has become 4x to the 1, but we don't really need the 1. Now here, when we flip the numerator, we bring it into the denominator. I can write this as 1/2 power, but I'll just write it as a square root. So I'll write it as 1 minus 4x to the fourth dx. And now just by rewriting it, it starts to seem like a u substitution is possible, but we don't really want to do it the way it is here. But if I take a substitution, if I say u is, let's say, the 4x to the fourth, we get 16x cubed. Not really that great. It doesn't really work that well with 4x in the numerator, but what I can do, if I just take this here, if I rewrite this as a perfect square, I can rewrite this as 2x squared, all squared. Then if I were to do a u substitution, notice the derivative of this is actually 4x. So let me just rewrite this to set the whole thing up. So we'll rewrite this with 4x dx here, and then this is going to become our 1 minus 2x squared, all squared, inside the radical. So now from here, let's try that u substitution. This is going to be the u, so we'll write that out. So u is going to be just 2x squared. Then we'll just take our derivative on this thing. We'll get du. Derivative of this is going to be 4x dx. But like I mentioned, that's exactly what we have in the numerator. So when we rewrite it, we're just going to have du here over the square root of 1 minus u squared. So then here what we have left is just a really common integral. I just like to remember the formula. The integral of this thing is actually going to be just arcsine of u. So all I need to do to finish it is just back substitute right here. And we'll plug that in. So for my final solution of this, we just get arcsine 2x squared, add a plus c, and that's it. Okay, so there you have it. Initially a pretty confusing looking problem, but when we flipped it, it just became an easy u substitution. So that's it for today. Thanks everyone for watching. Have a good day.